Hey, good morning. Today we're going to talk about how to store stuff locally to your phone so that your app can keep track of user data over time. But before we get into the actual how to do that, I think it's really important to understand kind of what's happening behind the scenes, understand a little bit of the basics of how computers work, and then also some foundational stuff about how iPhone is unique. So before we get into the uniqueness of iPhone and before we actually implement it in code, let's talk about what's actually happening under the hood. So thinking about your computer, there's kind of a handful of major components. So you understand what each one is doing kind of separately. And when I say computer, I mean literally your laptop or desktop, but also phones, tablets, even the little box that connects to your TV to let you stream Netflix. All of them really function in very similar ways and have basically the same major components. The first major component is called the CPU, and the CPU just represents the main thing that the computer can think about, or the main thing that drives the computer's brain. And so that's one major component. And again, you can think of that as kind of the computer's brain. It does the thinking. Another major component is a lot of other PUs. So the CPU stands for Central Processing Unit, but there's other kinds of things that do processing that do kind of mini thinking. And a common one is called a GPU. And if GPU is the thing that makes all the pictures look nice, it's the graphical processing unit. So if you had a nice little picture, it manages that. But on iPhone, actually, there's a whole bunch of other ones that you might not be aware of, things that are highly specialized bits of hardware. So for instance, in order to limit how much power is consumed, the thing that tracks how many steps that you've had is actually its own chip inside of your iPhone. It's a very low power chip. There's also something called the Secure Enclave, which is a series of chips and processors that manage all the security features of your phone, logging in and that kind of stuff. And they're separated from all the other stuff so that hackers and bad actors can't get access to that information. That's all side note. What I want you to really zoom in on is that there's a thing that does the thinking. And that thinking is actually similar to how your brain works, is spread out across multiple things that do the thinking. But the main thing, we're just going to kind of lump all those together as the CPU. So we're going to think about that as the main thing that does the thinking. There's also something that we call storage. And you can think of storage, if we're going to use kind of a metaphor of a kitchen, you can think of storage as kind of like your pantry where you keep all of your stuff. And so imagine that I have a pantry door and I open the pantry door, and inside the pantry, this is the inside of the pantry, are shelves. And on those shelves are bins of various shapes and sizes. And they hold things. And I might have something like my mixer might be sitting there by itself. That's a mixer, can't you tell? It looks really good. It might be sitting there by itself, but stuff just kind of in there. Also in your kitchen, you have your work surface. So you can think of this as like the kitchen island where the making of the food gets done. And so, it has some storage underneath it, but we're going to just kind of pretend in our example here that this is all that matters, the work surface. And this is what we would call memory. So every computer has basically these components: the thinking part, the storage part, and the working part. And I want you to think about, like, if I were to make some of my favorite cookies, I would go into my memory and pull out my recipe of the cookies. And that's this kind of like little card that might have all my recipes for my favorite cookies. And it would say, okay, you need this ingredient, this ingredient, this ingredient, and this ingredient. And so I'd go into storage and pull out the sugar and put it onto the work surface. And I would pull out the flour and pull it in the work surface. And I pull out the eggs and put it in the work surface, and the vanilla, etc. And then I would measure it out and do all of my work inside of memory. Now, I have a decent sized kitchen, but imagine that it didn't have a lot of work surface, but I had a really limited amount of work surface. What would happen then? Well, if I have a limited amount of work surface, I can only get some of those things out at a time. So instead of getting all 4 of these ingredients out at once and plopping them down in memory and working on in my work surface, I might only have enough room to bring out the flour at first and measure the flour out into a little bowl and then put it back. and then pull something else out and then put it back. And this is just an aside note. This is what happens when you're trying to do too much at the same time. It's not that your computer is getting slow, that the thinking can't get done quickly. It's usually that you're running out of space in memory. The computer can't be active with as much of what you're trying to make it be active with. So let's say you had Photoshop and Illustrator and InDesign and After Effects and Xcode all running at the same time, and then you try to launch Chrome, and now suddenly your computer crawls to a halt. It's not because your computer's gotten dumb or something. It's because you're just running out of working space. Under the hood, by the way, we call memory RAM. And storage, we call storage now, but these are SSDs and hard drives to some extent. And so these are just slabs of storage stuff. I'm not going to get into what a hard drive is technically and what an SSD is technically, but this is just big old space where you put stuff. And this is very quick, responsive space where you do your work. So when you launch an app on your phone, how's that work? You tap the little icon and it pulls out of storage all the information about the phone and brings it into memory so that you can work inside of that app. And then if you were to quit to the home screen and launch a second app, it would pull that app out of storage and bring it into memory. And then if you were to launch a third app, it would do the same thing. Now, eventually you're going to run out of memory. And so even though you think you're launching these apps, really what you're doing is when you launch the seventh app, for instance, it's pulling that app out of storage. And at the same time, it's putting app number 1 back into storage. And that's something that iPhone does that your computer doesn't do, which it manages its memory really, really, really efficiently because it's trying to save battery life. So the more stuff that you have kind of active juggling inside of memory, the more the CPU has to keep track of, the more battery gets drained. And so a really battery power conservation activity that one can do is take an app that's running in memory and just put it in storage. Now, I'll never do that with the app that's running in the front, the main app that you're trying to run. But you know how you can swipe up and see all the apps that you're running at the same time? Not all those may be running. In fact, the ones that are way back in the stack are probably already been put back to storage and aren't actually technically in memory. So when you see people on the subway or the bus or whatever swiping to get rid of their apps and they say it's because they're trying to free up something, that's all bogus. The system handles that just fine. And as long as the app isn't a bad actor, doing that does nothing. That's not to say that there aren't bad actor apps out there. We're going to get to those in a second, but that's just what that's all about. So the metaphor that I want you to remember is that we have the CPU, that's like the chef in our example of the kitchen. You have the storage, which is like the cupboard or pantry in our example, and the memory, which is the workspace in our example. And up until this point, what we've been doing is we've been working with the chef. We can launch the app and it can do things and it can manage stuff just fine for us. And when we're running our app, it's running in memory. That's totally fine. But we haven't touched this piece, the storage piece. And so what that means is that if our app were to be quit or the system were to quit it for us because it runs out of memory, then anything the user does disappears as if it never happened. And that's really bad. You want an app that can remember what the user's done. So if the user has a to-do list and then suddenly they launch their app the next day and there's no to-dos in there anymore, that's a bad feeling. So you want to be trustworthy. And so we want to be able to take what's in memory, what the user has been doing, and put it into storage. So as we move forward, I want you to remember this metaphor and this visual really well, which is storage is like the cupboard. It has shelves inside of it. And on those shelves, we have storage, things that go into those shelves. And so we're going to kind of talk about those shelves and use this metaphor to move forward. But just remember, that's the important part, is that storage, you don't actually make cookies in your cupboard or make cookies in your pantry. The stuff goes in there, the raw materials, but the real work gets done out on the workspace. And so that's the distinction between storage and memory. If you are unclear about that, I would encourage you to kind of rewind a little bit and rewatch this a little bit. So I'm going to clear out a little bit of space here, and we're going to talk about what is unique about iPhone. So a lot of this stuff that I just said, was developed by what I like to say is optimistic hippies in the mid 20th century, which is how I like to describe people that were working in San Francisco, in the Bay Valley, in technology circles. And they did some incredible stuff, but they never thought that people would really do bad things with their computers. And so that's why we have a lot of security problems with computers, is that the original creators didn't really think through the ramifications of what if you had your entire banking system running on these things. They just thought they were cool number crunching machines. And so there's all kinds of kind of built-in problems. And so one of those built-in problems in our metaphor here is that I could be following a recipe to make cookies, but a bad person can come in and tell my chef to also be making poisonous cookies. These are bad cookies. See, it has a skull and crossbone. That means it's bad. And so they could trick my chef into making poison cookies at the same time that I'm making good cookies. And so they could mix what's happening in memory and what's happening with storage with bad things. So let's say over in storage I had rat poison. I could have the bad chef could be taking out the rat poison and secretly putting some rat poison into my flour. And while in storage, or they might do it in memory. They might take it out and secretly put rat poison in while I'm doing my work inside of that. There's no protection if the entire system uses the same common memory and the same common storage. And so this is something that iPhone gets around. And so how it gets around it is that it sandboxes, what we call sandboxing, all of these things separate from each other. And so you can literally imagine like a sandbox that like a little toddler would play in. And this is their sandbox. And Billy's sandbox is separate from Sally's sandbox. And there's no sand that can move from Billy to Sally's sandbox. And so how that works in practice in iOS is that each app can only impact its own stuff. So the Billy app can only mess with Billy's stuff. The Sally app can only mess with Sally's stuff. And so effectively, the memory is kind of segmented into little chunks, and only this little area can be played with by one app. This little area can be played with by another app. This shelf can only be played with one app. This shelf can only be messed with by another app, etc. They can't mess with each other's storage, and they can't mess with each other's memory. And each one of these sandboxes is given a unique number. And that number is tracked centrally by Apple. This is the Apple symbol. And so if Apple sees that Sally is violating the rules and Sally is going out of her spot into Billy's spot, or Sally is messing with the pantry, then Apple will just simply say, meh, okay, I don't like you anymore, Sally. You're gone. There's no more Sally app. And they can do that in two different ways. One, they can actually say this app is no longer for sale on the App Store. They do that all the time. If you might remember that they did that with TikTok a year or so ago. Or they can do something more extreme, which is they simply delete it off of everyone's phones and remove it from the store. So you'll remember that before, you could still use TikTok. You just couldn't download a new version of it, or they couldn't push out updates, but it was still available on your phone. That's kind of like their low-end thing of when someone's doing something bad. But the high-end thing that they can do is simply erase it from existence as if it didn't exist. That says poof. So this happens more often than you would think, but not crazy often. They do threaten this a lot. So for instance, even more years ago, the company now known as Meta, then known as Facebook, Facebook was violating this rule all the time. They were listening to conversations. They were doing all kinds of shady stuff. And so Apple discovered it. Apple threatened to remove them from the App Store and said, hey, and wipe it off of everybody's devices and said, hey, Facebook, if you don't get your act together by Friday, then you're gone. And, everybody worked really, really hard to fix their stuff and to stop doing the things they're not allowed to do, and they fixed it. So that is kind of the back-end security that's happening, is that Apple is monitoring all this stuff, but also practically for what it means for us is that our stuff cannot mess with anybody else's stuff. So if we put one thing on one shelf, we can't mess with another app. And we can't know what's happening in that app. There's only a couple things. So let's say that we had Sally's sandbox disappeared. but say we had Kelly's sandbox down here. There are a couple things that we can do that are basically like tunnels that can connect the two sandboxes. And these tunnels are pre-built by Apple. We don't make them up. And so some examples of these that you've seen before that we'll talk more about as we move forward, but one example would be like sharing photos. So if the Kelly app is a camera app and it saves a photo to the photo library, the Billy app can request access to the photo library. And if you grant it, then you can have photos be shared between the two. There's other ones of these types of centralized repositories. So there's things like photos, there's things like health data, all that kind of stuff that you've seen these little pop-ups when you've used your iPhone says like, do you want to allow this app to do blah, blah, blah? That's building these tunnels between apps. And so that's some built-in things. Other things that are built in are copy paste. Again, every time or the first time you want to paste into an app, you'll get a dialog box that says, are you going to allow this app to paste? It's getting information from this other app. And so that's an example of some security features that are trying to prevent apps from doing bad stuff. Because again, one thing that they caught a bunch of bad apps doing was just reading your clipboard, whether or not you wanted to paste. And so they would keep track of you that way. These apps are going to do, the bad people out there are thinking of all kinds of crazy ways to get around the rules. And so Apple is constantly trying to plug those holes in their security apparatus. We'll talk more about how to build these tunnels between apps later, but just understand that it is possible. The main idea of today, though, is that what happens in your app in memory and what happens in your app in storage cannot impact any other app. So that's the big idea around storage, memory, and unique iPhone implementations of that stuff. And now we're going to get into actually how do we do it on iPhone. All right, so let's get into it. So I have my project here from the other day, and you'll remember that how this project works is I have a content view that has a struct, and it has titles, descriptions, etc. about movies, and I create an array of that struct and save it as a state variable called movies. Then I display that struct as a list. Please note I'm using the index way of generating a list, not the way that ChatGPT or whatever will show you. And then I'm cycling through that list and creating navigation links to go to another page, and I'm adding images and text and displaying it. Then that goes to the next page, and that next page is this detail view. These right here are just for placeholders for the design of the page. But what they're really doing is receiving the tapped index that you tapped on and the array of movies. And then it's taking that information and looking it up. For example, this title right here, how that's getting there is right here, where it's going to the giant movie array. Let's make this a little bigger. Giant movie array, looking up inside of it, the tap thing that you tapped on and pulling out the title. And then it does that however many times it needs to do that over here. So today what we're going to do is add data, saving, the ability to save data into storage and pull out of data from storage into memory when the app launches, what you've done last time. Now there's many ways to do this inside of the iPhone ecosystem. The most modern way of doing it is leveraging what they call SwiftData. And so SwiftData is what we're going to be using for this. There are many other ways of doing this. This is just the one that I would recommend. SwiftData is one word, camel case, so SWIFTDATA, no spaces in there. They capitalize D and they capitalize S inside of that. So capital Swift and capital D data. But SwiftData is pretty powerful and pretty useful and not very complicated to work with. And so it will actually manage a lot of the saving and loading of the information for you, where a lot of the other systems you have to do that manually. So we're going to kind of take a look at how this is set up. We'll do it an extremely manual way this time, just so you know how all the pieces fit together. And then I'll actually show you later how that this can be a little bit automated for you, made a little bit simpler for you using some frameworks that they have. But we're going to start with the kind of plain Jane version to enable our project to work. And so the first thing what we're going to do is switch over and change that struct that describes how everything is set up, and we're going to convert it from a struct into what's called a class. The important thing here is not to really understand the distinction between a struct and a class, but just know that SwiftData works with classes and not with structs. The good news is that it's actually pretty simple to switch between the two as long as you understand what they're doing. So I'm going to go ahead and change this movie struct, and it's going to create a lot of error messages down here. Don't worry about that. I'm going to change this movie struct from a struct into a class. And the first thing I'm going to do is simply change the word struct to class. One of the annoying things, you can see this error message is telling me I don't have initializers. The annoying thing about classes is that you can't just have this. You actually have to describe how one builds these things. And so it seems super redundant, but I'm going to go ahead and add instructions on how to build these things. Along the way, I'm just going to note that the word description is a reserved word in SwiftData, and so we can't use the word description. There's a couple of these other ones. It would try to be good practice just to get used to doing things like this in front of all of your stuff. So I'm using HP, not for Hewlett Packard, but for Harry Potter. And so if there's any of these kind of words, like title might be one that I know isn't reserved, but you might think might be. If there's any kinds of ones where you're kind of a little bit worried about it, just doing something like this is a good little hack around that. So for now on, whenever we talk about description, we need to talk about HP description. And I'll need to change that in my code a couple places, but we'll get to that as we go. All right, so in order to finish setting up the class, we have to set up these initializers. And again, the initializers are really stupid. In fact, it guesses what they are because it's pretty straightforward. I have to do this. It even generates it for me. That's really convenient. And so it just generates all this stuff automatically for me. And so that's pretty straightforward. You'll see that last time we added booleans to this. So I'm going to go ahead and add that functionality. Sorry, this version of the code that I had isn't from what we had last. And then do that down here. I have to add benzene as well. But I'm going to set it to false, just as it, so we don't have to like redeclare it down here. But just to be safe, I'm going to do that too. Cool. So this seems pretty silly, but it's just what you got to do. And then we can also do the sign of toggling that we did last time to this class. It didn't have in this struct in this version, so I'm going to add that really quick. Okay, so that's the first step, is I've converted my struct from something that was really pretty simple now into a class. And what we're going to do is take that class and say, hey, this class is a model for SwiftData to use. So I'm going to add in front of the class this. And all that does is says, hey, this is a model. And it's going to be an error saying I don't know what model is. And that's because I haven't done the next thing I have to do, which is I have to import SwiftData. So I'm saying, hey, I want to add, in the same way at the beginning when I first launched this project, it adds SwiftUI, which is saying, hey, this project is written in SwiftUI. I'm now adding all the superpowers of SwiftData to this project as well. And when the moment I do that, it understands what @model means. And so that error message disappears. So this is the basic setup for my class. It's really wordy, but you got to remember a lot of this is redundant. So this is the same stuff I was doing with my struct. This is the same stuff I was doing with my struct. And really the only thing that's special is this init. And the init's really annoying. It's basically just a little function that says get a title, get a description, get a release year, get a movie poster, and get a benzene. And then set these up here. Those are the self dots. Set those, so set title this way. And do the same, and it's using the title from here. And set description from here. And release year from here. And movie poster from here, and benzene from here. It's really annoying, but it's just kind of what you got to do. The good news is that Xcode usually write this stuff pretty well for you. You just kind of keep an eye on it when it generates it to make sure it's not doing anything super crazy. So that's the first thing we have to do, is convert our structs into classes. The next thing we have to do is go into a file that I've told you to never mess with, which is this one over here, the app file. This app file, if I click on it, Doesn't describe a lot, but this is kind of the basic structure of how the app is working. In fact, if you've ever wondered why content view is the first one, that's because it's being told it's the first one here. There's a handful of things that we can do inside of here, but the thing we're going to do today is add the ability to use SwiftData to this project. And to do that, I'm going to put in right here after the window group a modifier called model container. And what are we going to save inside the model container? Movie. Now yours might be Pokemon or whatever it is that you're making, but this is referencing the same name. So you can see capital M movie right here is the same name as that class that I created. So what it's doing is saying, hey, this project can now use that class as a model container that will be used for SwiftData. So it's saying this entire project can take this class, and that's one right here, and it is a container for that model. And so we're saying it is a model. So now we've done two things. So the first thing is we converted our struct into a class. To do that, we added a bunch of extra crap. And then inside of the app file, we added this one line. Be careful it goes where it is right now, which is the dot is attached to the window group. So it's right after the window group closes. And allows this window group to have that model container. So that's the second thing that we have to do. The next thing we have to do to convert our project is that down here, you can see I'm getting a bunch of error messages, and that's because all of this stuff, we're saying you can't have a default value of this stuff because it's being managed by that model container. So what it's saying is like you can't have default in memory, it's got to come out of storage. And so what we're going to do is remove this and say, you're right, I'm going to cut this to the clipboard. You're right, this thing, now movies is managed by SwiftData. This can't be hard-coded into my code. It's got to be pulled out of storage. Now, we're still going to populate it. You can't have just a list of movies that's empty. We're still going to populate it in our app, just not right here. The other thing we're going to do up here inside above the body is add what's called an environment variable, which allows the content view to monkey around with SwiftData. So to do that, we're just going to add right here, add environment. And I'm going to type it because it's not exactly how I want it to be. Model context. No, not the ones it was defaulting to. Private var model context. This run right here will now convert or allow content view access to the model context so that this is populated out of storage. Again, all these details don't matter. Just got to know this is kind of the hoops you got to jump through. So the big high level understanding is what matters. The next thing we're going to do is say, hey, we actually need to put some information inside of movies. It can't just be an empty array. It's got to actually list our movies. And so how are we going to do that? Well, how this is going to work is the moment content view is loaded, it's going to be like, oh, movies. I see that's something that you want to have based on the class of movie. And look, up here, the class of movie is a model, and that's coming out of SwiftData. And so I'm going to pull it out of SwiftData. So what we're going to do is intercept it right when it first launches the view. The moment this view comes into view inside of our app, we're going to make it so that we can intercept it and say, don't pull out of storage yet. If there's nothing in storage, then put in all these default values. And if there is something in storage, oh, then go ahead and pull it out of storage. So we're going to kind of intercept that flow using something that we haven't talked about before called onAppear. And onAppear will make it so the moment something appears on screen, it will intercept it and allow us to do something. So I'm going to put the onAppear after the list. So right here. And I'm going to say what I want to have happen when it onAppears. And what I wanted to do is load movies. We haven't made load movies yet, but we're going to. That's why the error message is saying, I don't see that. Where is that? So let's go ahead and create load movies. And load movies is going to go and check storage. And if movies has already been stored in the storage, which means the app has already been launched in the history of the world, then it's just going to pull out the movies out of storage. If it hasn't been launched, so this is the very first time the app's ever been launched, then it's going to go ahead and populate it with the movies in the order that we want. And so then from then on out, it has it populated. Now I'm going to copy and paste some code, or paste some code in. The first thing we're going to do is check to see, well, what thing do we care about? And so what I'm going to care about is movies. So this code right here, don't worry about exactly what it does. It's just doing that. And then what my code is going to do is say, all right, go ahead and try to fetch some movies out. And if it is successful, in other words, if the result is not empty, then just make movies be the result. So if you already have movies saved, load the movies. Otherwise, and this is the stuff that we're going to use to populate it. And again, I'm going to give you this code you can use as a starting point. Otherwise, let's go ahead and set up our movies. So I'm going to create a variable called HP1 for Harry Potter 1. And it is equal to a movie. Look at that thing go. He did a pretty good job of guessing. Movie title. We'll say the first title is Harry Potter and the Sorcerer's Stone. And then remember I had pasted, I have in my clipboard all of these, that array from earlier. I've gone ahead and pasted it into another document, and I'm just copying stuff over. The release year was in 2001, we think. I don't know if that's correct. And then the movie poster was named HP1. So I've created my first movie. Next, and I gotta do this for each movie. It's not as convenient as an array, but it'll work. HP2. Harry Potter and the Chamber of Secrets. And I have my description from before. Copy that over and paste it in. Cool. Now I've created my two movies, but I actually haven't put them into storage yet. So I'm going to go ahead and put them into storage. The storage is called the model context. I'm going to insert HP1. Next, I'm going to insert HP2, etc. And then I'm going to save it. So I've inserted these two movies. I hope I spelled that right. I've inserted these two movies into the model context, and then I'm saving the model context. So you can see, think of this as I'm putting these things into a bucket, and then this is taking that bucket and put it into the cupboard. And then last but certainly not least, I'm going to populate my movies array with just those two things, HP1 and HP2. And so let's just work through this again, what load movies is doing. First, it intercepts the moment the app loads, it runs on load movies. What's load movies doing? Well, first, it's doing this stuff, which this stuff is doing is checking to see if there's anything saved already. If there is something saved already, just load it up and make those results be what movies is. And remember, movies is this guy right here. Otherwise, run this code. So this only happens the very first time the app launches. We're going ahead and making HP1, then we're making HP2, then we're taking each of them and inserting them into a bucket, and then we're saving that bucket, and then we're setting movies for this view to whatever those are. So that's the main thing for that. Still not done yet, but the big 3 steps we've done so far, let's roll through it. First is we've converted our struct into a class and added model and imported Swift data. So that's the first major thing we did. The next thing we did is we went into the app and added a container to manage that. And note that I've named this the same name as this. Then what we did is in our content view, we made it so this content view can have access to that model context, access to that storage. Then what we did is say, hey, movies aren't always one thing. They're going to be changing depending on what's in storage. So we're going to make them empty. Then what we did is on the list, you can see this is after the list code is over, I've added on appear so that the moment that list appears on the screen, we're going to check something. We're going to intercept that workflow, and we're going to load movies. Load movies is this function here, and it works just like I said. So I'll walk through it one more time. At the beginning here, it's just simply saying, hey, if there has been anything saved into storage, load it up and use it. If there hasn't been, so the very first time the app ever runs, if there hasn't been, then populate it with some stuff ahead of time. And how we're doing that is creating 2 classes. One's called HP1, one's called HP2. Yours would be HP3 or HP4, HP5, etc. And then we're inserting into the context, into the storage that the app is using, the first one, and then the second one. And then we're going to save that thing. And then we're going to pre-populate movies with an array of just HP1 and HP2 for now. The last thing we have to do to this page, we still have to mess with detail view, but the last thing we have to do with this page is fix the preview, which is probably what this error message is giving me. To fix this preview, I was going to say, hey, this preview also is going to use the storage. And so I'm going to modify, so we're going to do the dot modifier. I'm modifying content view inside the preview to show a model container. And what's the thing that's going to be modeling? It's going to be modeling movie. And this is just a setting that I can change for this, but I'm going to turn on in-memory true. So this simulator will actually simulate as if it's a real app that runs multiple times. So that's it for the content view. Let me just make sure I'm right about that. Yep, no error messages in content view. So content view is ready to go. Next, I have to do a little bit more tweaking on detail view, and then we'll be good to go. So let's go over to detail view. Inside of detail view, sorry, I have the same problem where I'm not allowed to have stuff pre-populated if I'm going to be using it from a previous page. So I'm going to go ahead and remove this. The moment I do that, I need to also delete the preview. So I'm going to delete the preview. I don't need that anymore. And then at the top, I need to add the ability to save and load inside of this page too. And so that's an environment data. And I'm using the exact same environment code that I used on the previous page. And so that's how I set that component up. And then most of this, I don't need to do anything to. Remember, I had changed the word description from description to HP description. And so now it will work. So I'm going to click through from content view, and we'll see it's doing its thing. So let it build. And so now you can see it works just like it used to, only it's no longer using structs, it's using classes, and all this is being pulled out of storage. Now let's actually make a button that uses that storage. So I'm going to use the same type of button stuff that we did last time, but you'll remember last time it was only changing it in memory, it was never impacting it from storage. So if I made a change inside of whether or not I'd seen the movie or not, it would forget if I had seen the movie or not. Now I'm going to make it so it works forever. And so to do that, we're going to modify detail view. Now I'm going to make my button fresh. You can use the button code that you might already have. So this is the action label type. And as usual, I'm going to start off by putting curly brackets in for the action and curly brackets in for the label. And inside of these curly brackets are going to be what happens when the button gets tapped. And inside of these curly brackets is what the user gets to see. So the label is pretty straightforward. I'm going to do the exact same thing that I did last time, which is if movies tapped index dot been seen is equal to false, then mark as seen, otherwise text mark as unseen. So this is the same as before. It's just changing what that label looks like depending on the value of each one's been seen. The action is going to be at the beginning, the exact same action we did last time, which is movies tapped index dot toggle scene. So all this is doing is running toggle scene inside of the class and toggling if it's been seen or not when you press the button. But then here's the new part. It's really small. We're going to save it. So because all this is happening inside the model, anytime that I make a change to it, I just have to simply save it. And if I save it, it'll be ready next time. So try model context.save will just save this movies array. I'll explain what try and question mark means later, but the important part here is that what this is doing is simply saving everything that's possible to storage. And so anytime I make a change to my movies array, I need to just run this try model context.save. Now in this app, that's only this point when I'm changing whether or not when I'm toggling whether or not it's been seen or not. But in another app, you could have a to-do list app, you can imagine, where I'm creating to-dos on one screen. And when I create to-dos, I need to immediately then save it. And then I might have another screen where I'm toggling if I have completed the to-do or not. And the moment that I toggle it, I need to do the same thing again. And so this just kind of keeps everything in sync. So let's test it. We'll go back to content view, run through it. And it says, oh, I haven't seen it yet, so it has been seen. If I click on this one, it doesn't impact this one, but it will remember it from last time. And if I quit this and do it again, it will remember it from before as well, because it's now saved in the storage. So there you go. Now we have successfully saved it. We can double check to make sure that it's worked by building to the simulator. Because remember, sometimes this little preview thing doesn't work exactly how we'd expect. So I'm going to preview it to an iPhone 16 Pro by hitting the play button right here. This takes a moment to launch. And we'll wait and watch it. There it goes. Installs my app onto the phone automatically. And now I can click through it. So, all right, I have seen it. So if it says seen when I come back, that means it worked. And if I come back, this is still in memory. So it's working how I'm expecting, but I haven't checked to see if storage has worked. To check to see if the storage has worked, I'm going to double click on the home screen and swipe up on this to kill the app. And then I'm going to come back into the app. And ta-da, it remembers that it's been seen, because it's pulling it out of storage. This one is unseen, and so there we go. So the app works as expected, all the storage happens as expected, and now we have added SwiftData to our project. If you have any questions, reach out, let me know. Otherwise, I'll see you next time.